All right, welcome to the worksheet on multiplying linear factors. So we're going to take these linear factors here, we're going to multiply them together and change them into standard form. So we're going to do a few examples together. They're all kind of the same. The first page is simpler than the second page. One of the things that I tried to do differently here is I tried to include the ones that have the numbers with the x. And that'll be important for the next worksheet, is paying attention to what that number does there. So here we go. So we're going to do x times the 2x, so we get 2x squared. X times the 1 is just x. 3 times the 2, 6x, and then 3 times the 1 is 3. So we're going to now add the like terms together. These are the same, so we get 2x squared plus 7x plus 3. And there's the answer to that. All right, let's look at the bottom of the page here. So all of these are pretty much the same. Now look at the bottom of the page. It's called the difference of two perfect squares once we multiplied it together. So notice it's x plus 4 and x minus 4. That's a very important pattern in algebra, is when the x's match, the 4's match, but one's plus and one's minus. So we're going to multiply these together doing the same thing that we did up here. We're going to multiply the first times the first, the outsides together, the insides, and then the last. So look at number 7 with me. Outsides multiplied together, x times x is x squared. And then x times the negative 4 would be negative 4x. And then 4 times the x would be 4x. And then minus 16. These are the like terms. They go together and create nothing, because you got negative 4 plus 4. So the answer is x squared minus 16. So this is a factoring pattern, and a pattern that happens when we do different things in algebra. There's a fancy word with it, conjugate and all that stuff. But basically, this is a perfect square. That's x times x, and this is a perfect square of 4 times 4. So we call this the difference of two perfect squares. X squared is a perfect square, and 16 is a perfect square. So the answer is x squared minus 16. And you'll see that pattern happen. So going from here to here is just as important as going from here to there. All right, so all this page is just two binomials multiplied together. Let's flip to the back side. Here we have the thing where there's 3 of them multiplied together. And again, I tried to include some of this stuff where there's the 2x instead of just always being x. So that's my situation with that. You're not allowed to multiply 3 things together at once. So I suggest covering this one up, multiplying these together, simplifying it, and then multiplying by that. This was on the quiz, but some of you need some more practice with this anyway. Plus, we're going to be tearing these apart, so this will be good practice for thinking about how these are torn apart. X times x is x squared. 2x minus 3x and negative 6. All right. These are like terms, so we get x squared, negative 3 and 2 make negative 1x, and minus 6. All right, so each time this would still be multiplied by 2x plus 1. 2x plus 1 equals. So there we go. Now we're going to do the clam-a-claus, oh clam-a-claus, right? So we're going to multiply 2x times all of these. It looks like a clamshell. And when I do this in green and red, it looks like a Christmas clam. And I call him Clam-a-Claus, from discovering that on the internet. So here we go. 2x times x is 2x cubed. 2x times the negative x would be negative 2x squared. 2x times the negative 6, it means negative 12x. Multiplying by 1 is easy because you just copy it down. I can write minus x or minus 1x, it doesn't matter. So I get 2x cubed. The x squareds go together, so it's minus x squared. The x's go together, minus 12 and minus 1 makes negative 13x minus 6. And there's the answer to this one. So that's the standard form. That is the factored form up there. Let's do one more together. Oh, look what's going on with this one here. I kind of kept it the same as this one, but then it has that pattern of x plus 5x minus 5. So I tried to add that in there to kind of keep it fresh and real. So again, cover this up. Let's multiply these together first. X times x is x squared plus 5x inside negative 5x and last negative 25. Those cancel out. That's the beauty of the difference of two perfect squares situation, is it cancels out. So I just have this binomial left. So now I have a binomial times another binomial. The difference is, from the first page, is this would be 3x and that would be x on the first page. See how it's like an x times a 2x or whatever. But I have to keep track of the exponents to make it be bigger. Excuse me. Equals, put parentheses around this, parentheses here, 3x plus 2. All right. So 3x times squared. That would be a y. 3x cubed. So 3x times x squared is 3x cubed. 3x times the 25 would be negative 75x. Multiplying by 2 just doubles stuff, like Oreos doubles stuff. 2 times this would be plus 2x squared, and then doubling the 25 minus 50. This is out of order, so we want to make it be cubed, squared, x, etc. So it's 3x cubed plus 2x squared minus 75x minus 50. And that would be in the old standard form. So there's factored form here, standard form down there. Again, factored form allows us to see the x-intercepts really easy. Standard form allows us to see the leading term, which has the leading coefficient and the degree, and then it lets us see the constant term. So the cube, right, it helps us to know the shape of it, and the 3 helps us to know the end behavior, and the negative 50 helps us know where it crosses the y-axis. And then up here, these numbers tell me where it crosses the x-axis. Then that's how we can make our graphs of it. So have fun practicing these problems here. And this is on multiplying linear factors, changing it to standard form.